Hey everybody, I'm Paul Myers, and this is another development video for Bolero Tactics, a tactics slash adventure game I've been working on off and on for a couple years now. And the specific topic I'm going to go over today is how I am achieving the three-dimensional perspective shifting effect, because I've had a lot of people, asking me how I did it. So, I guess the first thing I should mention is where I got the idea from, and it's from the 2009 or 10 or 11 remake of Tactics Ogre, another tactics game, which was made by the same people that made Final Fantasy Tactics. As soon as I saw that effect in Tactics Ogre on the PSP, I was like, why is every tactics game not doing this? Because you can do it at any time, and it brings a new perspective to the battlefield, which is often very useful for planning out your attacks and getting a better sense of where all the units are in relation to each other. And plus, it just looked friggin' cool. So, when I got to that stage in development of my game, I thought, hell yeah, I'm gonna implement this. But I soon realized that it's the reason why every developer isn't doing it in their game, because it's not trivial. It's actually kind of difficult. And what made it even more difficult was because my game is in a two-dimensional engine. So it's basically one big illusion. And so I think that's why a lot of people on my Twitter were very interested in how I was achieving it. So yeah, I've got my Photoshop open, and I'm just gonna, try to draw out the way I was thinking, and I'm gonna try to explain it to you guys. First things first, I'm gonna tell you guys how I am constructing the environment in my level, and it is in the unit of tiles. So each tile roughly looks like this little guy. So there's a certain number of pixels here for the top of the sprite. The top, it's really just one big sprite. And I actually had to measure these out accurately. I used a bit of trigonometry to figure out how many pixels I actually wanted to be using, because the ratio matters between all three of these to make it actually look a little bit realistic. So yeah, let's say this is a dirt tile. Yeah, so the whole environment is made up of these rectangular sprites, and there's a few tricks I use to be able to use larger sprites to make up the environment, but basically these are the building blocks. And for my game, I used a bit of trig to figure out the right ratio, but the horizontal element is 22 pixels, the top is 12 pixels, and the front of the sprite is 6, so that's a total of 18 over here. And when I load these sprites into the game, I actually split it up into two objects, the top and the front. And that's using the cropping feature in the Godot engine. This is actually the top of the sprite, which is cropped to only the top 12 pixels, and this is the same sprite cropped so that it's only the bottom 6. And it is combined in the game so that it looks identical to the full sprite at the regular perspective. When I shift the perspective, I'm actually have a value of these pixels that I'm shifting it to. So when the game starts, it says, so let's call this the Y element, and this is the H element for height. When the game starts, it knows that the Y element of the level sprites is going to be 12, and the height is equal to 6. So for more of a top-down angle, you want the, I guess we should call this X2. You want the Y and the X to be equal. So let's do this at 22. So this is when the game starts, the diagonal perspective. For the top down, you want the X and the Y to pretty much be equal and the H value to be very low, because so it'll look more like this. So this is the same sprite, but you want to just scale them so that it looks more like this. So now it's 22, 22, and maybe the H is now 1. So in Godot, you can interpolate pretty much any properties or variables or the size of sprites in the engine, which has been very useful because it's sort of like a catch-all to change a variable over time. And I use it for a lot of elements in my game. And it's called the tween object in Godot. I've never used Unity, but I'm sure there's some analog to it. The tween.interpolate property. I didn't spell that right. Yes. And then there's a whole bunch of parameters to get whatever effect you want. But basically, I am both interpolating the Y and H global values. So when you press the button to shift the perspective to the top-down version, so this is the regular front diagonal element, and then you press the button and it's shifting to the top-down. There's the global saved value for what Y should be, which is being interpolated from 12 to 22. And you are, at the same time, you are also interpolating the actual scale of the sprite you're looking at. This is maybe 6. This is going to H equals 1. So you both interpolate the global value and the actual scale of the sprite. And you do this with every sprite. That accomplishes one aspect of changing the visual of the game, but also the placement of the tiles in relation to each other has to change. So the way I achieve this is when the level loads and all the sprites are together, they each have a coordinate in the world, each of the elements of the environment. So let's say these are 4 tiles in the world. Let's say this one is at the coordinate 0, 0. This one is at the coordinate 1, 0, 1, 1, 0, 1. Okay, so when I'm placing these in the world, this is 0, 0, so I place it at coordinate 0, 0. But then when I want to place this one, you have to actually look at these numbers for where you want to place it. So you take the coordinates and you just multiply them by the pixel values. So this sprite is going to be placed at 22 pixels to the right and 0 down. And then this sprite is going to be placed 22 pixels to the right, 12 down. And this one is going to be placed 0 pixels to the right and 12 down also. And you can incorporate the height element to this also. So let's say this one is in front, but it is 1 height lower. I neglected to write it down, but these also all have height coordinates too. So this one, let's say these are all at height 0. This one would be, let's say, 0, 2, and now it is -1 for the height. So that means because of this height element, you have to incorporate the 6. So it's also moved 6 pixels down. So the actual function is, let's call this let's call these the positions. So the vector for where you're placing each tile is, let's say, position dot x times the global x. So that gives you the x coordinate. And in all the perspective shifting, the x actually never changes. When I'm shifting for the perspective, I'm only changing the y and h. So this value actually will never change for where they're placed. And I'm running out of room. But for this, you want to do position for the y value of the vector where you're translating all the tile sprites to. You do position.y times global y, and you then subtract the position.h times global .h. So you can see how that makes sense. It's lower, so you're adding more pixels that you're moving it down. So you do -1 time, you subtract -1 times 6. So you're adding 6 pixels to move it down because it's lower. If it was higher up and this was a 1, you would actually be subtracting 6. So it would be closer to the 0, 0 coordinate. All right, so this is the basic formula for how I am positioning the tiles. So in this process over here, where it is all shifting, the interpolation is happening. I'll use that big arrow. You're also, well, let me say, when you press the button and you start the interpolation, there is a goal, basically. My goal is to get the y12 to y22, to get the scale here to the proper proportion over here, and also to shift whatever the position is of this sprite here. You calculate where it should be with the new global values, and so you calculate that when you press the button, and then you interpolate it to that next position. By recalculate the position, I mean if this tile's coordinate is 0, 1, 0, so that means when you're placing it in the world, the vector for placing it is 0, and then 1 times what it started out as 12 minus 0. So then the ending would be 0, 12. So then if you're changing the y to a 22 value, you're also interpolating that 12 to become 22. I am now able to interpolate between basically this perspective and this perspective. So we've got the global values of what y and h should be. We've got this sprite shifting to this height. And then, so remember, these are two separate sprites. So we've got this sprite stretching to look like this. We've got this sprite. It's not really that clear right now, but it's getting a lot thinner when it's going to top down. So we've got that sprite squashing to look like this one. And we've also got the whole thing, which is all stored in an object. We've got this whole thing being translated to the new position that we calculated using these new global values. Are these new global values? That's a lot of arrows. Also be aware, I will be taking questions about this. So just if you want to know any more, and if any of this is not clear, just like post in the comments, hit me up on Twitter. I'd be glad to explain any more of this if it's not clear. So we have this process shifting perspective to this, but we need to be able to make it fluid. So in my game, when you hold down the button, it will start shifting, and when you let go, it won't continue to interpolate from this one to this one. It'll stop at some point. So I press the button now. After, let's say, half a second, it should get to this point. But what if you let go here? Basically, if the player lets go here, I stop all of the interpolations happening. And that means these values that were going from 12 to 22, that also stopped somewhere. Like, let's say it's now like 16.234. And this height that was going from here to here, it stopped at the... Now, I don't want to have to calculate it, but that looks like it would be somewhere like at 4. Now the game knows that this is the new value that the coordinates of anything being placed in the level will use for that function. You know, where I wrote down vector 2 to position dot x times global x position times global y. So that global value is now that it's using to place objects in the world. That is now some weird value that's in between the two pre-programmed goals. So yeah, now if I stopped it here and these are the new global values, and I press the button again to shift down or up, shift the perspective down or up, it's now going to interpolate to this pre-programmed one. If I hold the button down, it's going to finish that, and if I let it go again, it's just going to find a new value. The global value is set to something, and when you press the perspective shift, it will go towards a pre-programmed value I've set. So the maximum pre-programmed value for y is 22 because the x value is 22, and for a top-down perspective, the tiles are squares. And for this whole process, I basically, for the front-on view, so if this is the normal one, if you shift the camera down again, then the y value will actually shrink and the height element will grow. And the whole process I described, basically, it works the same way. You have a goal value for the global. Now the y might be equal to 2 and the h equals 10. And the default y is 12. Default h is 6. So now when you're shifting that, you're interpolating those global values to the goal. And you use the goal values to figure out the position you're going to be interpolating to. And you do this with every tile in the entire environment. So it's kind of a taxing process on this, the CPU or the graphics card or whatever. I don't know much about hardware. And I do want to find a way to make it less of an expensive thing to perform. But I'm keeping it in right now because it looks cool and it's functional and it helps with gameplay. So I think I covered most of the topic. If you have any, like I said earlier, if you have any questions, just like shoot me a message, post in the comments, and I think I'll be very attentive getting back to anybody. And yeah, follow me on Twitter. Check out my Patreon page, you know. This video will be posted December 1st there, and a month later I'm going to post it on my YouTube publicly. If you want to support the project, you're going to get early videos and monthly builds of the game that you can check out and see the progress I'm making, actually play through it. And I'll try to make sure those don't crash too much. So I hope you enjoyed this one. I hope it was informative. I'm also thinking of doing some Twitch streams, which should be fun. You can come hang out with me. And I think I'm going to start out doing level design on those because it's more of a free-form thing. I could listen to Twitch chats, suggestions on like where to place tiles. That sounds like it might be fun. So yeah, thanks for watching. Gonna get out another one of these videos next month. And let me know what topics you'd like to see me talk about. Maybe something a little simpler next time, less mathy, but this is what you guys told me you wanted to hear about. So there it is. Have a good one. Stay safe, stay healthy. Bye-bye.